Okay, I'm gonna make a character marker that is gonna be projected on the floor, which follows a position of the characters to show where the character stands on. I'm gonna make that using the shader graph using Unity 2018 0.1.0 beta 4. The newest release came on 2018 January 27th or 6th, and the latest version is 0.1.16, and it could only be opened using Unity 2018 0.1.0 B4. So gotta be careful about that. Now if you download this, you'll see a folder called Material Graph Project. So you just copy it somewhere on your directly and open it using the Unity 2018 0.1.0 B4. And using that, you can using that project file, you can use the shader graph. Okay, now let's set up the scene first. I'll make several folders that I need. Scenes, shaders, materials, and what else? Materials, scenes, shaders. I guess that's it. Okay, let's save the scene first inside the scenes folder. I'll call it main scene. Oh yeah, I need one more folder, which is a scripts folder. Okay. Now let's set up the floor and the character first. Okay, now I'll make a floor. I'll set the size to 555. And I'll make a sphere as a character. Okay, and also I'm gonna set the camera at somewhere at this view. I'll click the camera and game object, align with view. Okay. Now, maybe I can close up a little bit more. Okay, now I'm gonna make a script so that the ball as a character would follow your mouse on a game view mode. So when you move the mouse, the balls follows you around, so that you could see that you could test out the marker that's gonna follow the character. Okay. Now let's create a script. Name it follow and attach it to the sphere. And let's write some simple script. Right. Okay. So in the void update, I'm gonna use the ray. I'm gonna create a ray using the camera main screen point to ray and convert the input mouse position. and create a array cast hit. And if the physics raycast ray out, oops, hit, now the hit dot point would be the position which is on the floor where the mouse is pointed at. So let's get that first. Vector 3, I'll name it mouse pos equals to hit point. And also since I want the balls to move towards this mouse from this ball position, so I'm gonna have to do some vector calculations. So I'm gonna make a direction vectors and make a hit point first, minus transform position, and then, well, since the sphere itself has a height of 0.5 right now, so I don't want the direction to have a y direction, so I'm gonna set the y direction to 0, right? And float speed, I'm gonna set the speed, how fast the ball should follow the mouse. I'm gonna set it to 0.1f, and if the direction's length, I mean the magnitude, is more than speed, then move it. Set the direction size. First I'll set it to 1 by normalizing it, and actually translate the sphere by direction times speed. Okay, saved it. Let's go back and check that the follow script is on the sphere, and then let's save the scene. If I play it, the ball, yeah, should follow like this. Should follow to the mouse. Okay. Now the setup is okay for now with this. I'm gonna make a new shader so that this gonna be a shader for the floor to actually draw a marker for the character position. So let's go do that. Create shader graph, and let's name it character marker. And open the shader editor. Right. And let's start doing some shader cooking. Now, first thing first, I need the position to actually calculate the shader position, the marker position. So that I need to input the property, or should I say the blackboard, for the character's position. So I'm gonna make a new blackboard here. It used to be called property, but it seems it's changed, I guess. So I'm gonna make a vector 3 blackboard and name it position pos as a position, and create a node. Is it a property? Yeah. Okay, so I have the property position here, and I'm gonna use it to actually calculate the distance. Okay. Right? Well, right now it's 0, 0, 0. And what the default value is 0, 0, 0. And what I want to do is that, let's say this value is the position of this character at the foot point. And what I need to do is that I need to calculate the distance between I need to calculate the distance on the surface for like in each pixels of this view. And for that I can get each pixel's position using the position node. And I'm gonna use this to actually calculate the distance. So there is actually a distance node. So let's connect two together. Right. And let's see what it gives you as a result first. And let's save this asset and let's make a material. Also name as character marker. And use the shaders that I just created. Character marker, yes, this one. And put it on the floor. And I can dimly see the black circle on the floor. Yeah, and I assume this is a length of 1. After the 1, the value goes more than 1, so it's all white right now. Okay. Now, next thing I would need is a vector. Since I want to make some wavy patterns on the circle, I'm gonna do some angle calculations from this point to actually get the angle of all the directions, 360 degrees. So in order to do that, let's make a vector by subtract, and I'm gonna make a vector that goes from position to the center. Right. Okay. Now, well, I guess it's going from center to the outside surface. This one. And from here, I'm gonna normalize it first, since I don't need to have the lengths. Oops. Normalize, yes, this one. Okay, well actually let's try connecting it to see how it looks like. Okay. Okay, doesn't really mean anything to me right now. Now after this, I'm gonna, well, since the floor is on the X and Z plane, I'm just gonna extract X and Z and make a wave on the X and Z plane. So this value is right now a 3 vector. So I'm gonna split it first to float numbers or double numbers. And I'm just gonna use X and Z value to actually calculate the angle for each direction, for every direction on the surface. Let me check first about the... Okay, I think I need to connect it on the other side, since I want to make a vector from the center to the outer position. So it should be position minus the center point, I think. Okay, now let me explain a little bit what I am gonna do. So let's say you have the surface and you have the character's position, and for every pixels on the surface, you're gonna first give a vector, and first calculate the angle here. And use that angle to somehow modify it to make a waves like this, using cosine times something like this. So if you need 5 waves, you can multiply the angle by 5 and you'll have this kind of wave. Now let's draw that. Okay, so first thing first, I need to calculate the angle, and I can do that using the A arc tangent 2 and connect the X on the B and Z on the A, which should give you the angle, I think. And let's multiply it by some numbers such as 5, which will be the number of the waves, and let's connect it to the cosine. And let's see if this thing's gonna work. First of all, so since this is a cosine value, the range is between -1 to 1, so I'm gonna remap it to 0, 1. And let's see how it looks like. And yes, I am seeing a wave, but in infinite lengths, But so far so good. It is kind of working. And one more thing I would like to do, I would like to animate this wave, such as rotating it, and maybe have the radius of the marker to be changed, also animated as well. So let's do that. So in order to animate it, let's time. Let's get a time. And let's also create a blackboard parameter or property, whichever you called, and float number, which should be this one, vector1, and I'll call it speed. And as a default, I'll just set it to 5 and get a speed property and multiply it. Multiply the time by speed to control how fast it should animate it. And then what I would do is to, okay, after I have set it the number of waves here, I would add the value, the time value plus the total wave related angle in radians. Okay, now I will connect it to the cosine, and I can see some changes on the preview already. If I save it, yes, it's rotating now. This itself is cool itself. I mean, if you look at the parameter for the materials that I just made, or shaders I just made, there's a parameter called position on this material. So if I change this, the center of this rotating flower, black and white flower, changes based on the position here. So, well, in the end, I have to link this position with the position of the sphere. But for now, I'm doing manually. Okay. Now next thing, okay, I'm gonna also make a cosine, another cosine from here, and actually use this to make the amplitude of the wave, which will be a wave around the sphere, around the characters, to change, the amplitude to be changed. Okay, so I also need to remap this, and which will be from -1 to 1 to, let's say, I think I can also set the parameter for this one. So I'll set it to something, okay, vector2. I'll name it wave scale. And let's say as a default, I'll set to 0.5 to 1.5. And I'm gonna bring this wave scale property and put it on the output of the remap. Okay. Now, next thing what I need to do is that, well, I have to somehow reduce the size of this. Right now it's infinite flowers, but I want to reduce it to the certain radius, which I'm gonna set it as a property as well. So I'm gonna make a new property called radius, and let's say it's 3 as a default, and get it out, and use this radius to actually control the radius of the marker. Okay, now first thing, I'm gonna use this remap, which is controlling the rotating things right now, and set the out min and max to be come from this one. So I'm gonna have to make two vectors, vector2, so combine. And I'm gonna set the first value to be 1, and I'm gonna set the second input to be 0.5 to 1.5. So basically the first one will always be 1, and the second one would change from 0.5 to 1.5. Right? So let's save this. Now this information itself is gonna be used as a guide or the trimming filter. And that is what I'm gonna do right now. Okay, first of all, let's multiply this value by radius. Multiply. Okay, like this. Save it. And also from the distance, which I kept it for a long time. Well, I'm gonna create a preview so that I can make it longer. I'll bring it up here and actually connect the preview and the radius together using a node called minimum. So that the minimum value will be picked from this one and then the distance. So if the distance is more than, say, 3, the radius, then it's all gonna be 3. And if it's less than 3, then it will be from 0 to 3. Okay. Now, after this, now this will be the maximum number I guess. Yeah, the radius 3 is gonna be the maximum right now. So I'm gonna make a division, divide. So connect the minimized minimum value to the first input of divide and connect this multiply value on the second input and save it. Let's see how it looks like at this point. And I am seeing something under center and specific radius, I think, but I still also see some patterns outside this radius. So I should get rid of the outside one and just get only the inside one, inside patterns. Now, in order to do that, but I think it's a bit strange here. Yeah. Let me connect a round first, and let's see how it goes. Now it is doing something I want, but I also see some weird lighting effect, whitey effect outside, so something must be wrong. Okay, let me check. Okay. What if I change this to, 1, save it. I gotta change it here. If I change it to 1, oh yeah, so this is the things. I always needed to make it this to be more than 1, I guess. If I change to 1, it will be circle. If I increase the value, oh wow, if I increase it too much, I see some weird patterns now. Yeah, I think I need to fix this thing. Now let's see what it's doing. So I've set the remap from cosine and also remap this cosine value. Right, yeah, at this point it's okay, I think. And I multiply this. And well, the thing is that at this point I cannot really tell if this value is in what range, I think. Let me just connect this to this thing. Yeah. And well, okay, well, what if I, oops. If I connect it to this one, nope, not really good. I'll just divide it here and let's clamp it. Well, okay, let me check again. So this is the distance. And I have set it, well, this is kind of a clamping, right? So if I set it here, sure. And right, right now I'm calculating to minimize just using this radius, but the radius is already modified here, so I think I have to connect it here. And after that, so this will be the maximum size. This is the value that changes by the time value. So yeah, this will be the maximum, I think. So I divide this value that's on the surface, which could be from 0 to the value of about the radius, and to the maximum, which will be like 0.83 or something. And that, as a result, I used the round to round it up. And yes, seems like I'm getting correctly. Now if I change the wave scale, it doesn't give me any errors. Pretty interesting. Alright. Yeah, looks good. Looks really good. Now I also wanted let's say I want to change the color of the base floor color and also the color of this flower shape. Now let's do that. And in order to do that, for this one, I'm gonna set it to 1. I'm gonna connect the 1 minus. And let's make a new property called color. And let's name it marker color. Also, I need one more colors, and let's name it surface color. Okay, and first of all, I'll use the marker color. Let's say I want to make it red, and multiply. And put it on here. Alright, now I have the marker as a red. What I need next is the floor color, the base floor color. So for that one, I could just simply put a multiply to this one with the surface color, and I'll set the surface color to something, let's just say white. And finally, let's add the color, this one and this one. And if I save it, and let's change the surface color. Oh yeah, and it is working just fine. Yeah. Now, last of all, I want this marker to follow these characters. When the character moves, I want the marker on the floor to move as well. So let's do that. I think I don't need to change the shader anymore at this point, so I'll just save this and close this. And all I can do is to actually modify the parameter of the shader, position, speed, wave scale, and those two colors and radiuses. If I change radius, you can make it small. We can change. If you scale it up, it will be bigger. Now, what I would want to change in order to follow the characters is to change the position, obviously. So let's do that. I'm gonna just add a function on the follow script that I set it on the sphere, which should be the easiest way to do it. So I'll make a public variable call for the material. Let's say character marker matte, and character marker matte set vector. So I'm gonna have to set the vector position. And first of all, in order to do that, I need to check the name of the property, the proper name for the property. So if I go to the shaders folder and click the character marker, I see that these are the actual name in order to access to the variable, in order to set it using the script. So this one, vector3 337 113a will be the proper name in order to access the shaders property. So I'll set the vector to this vector 3 underscore 337 113a, and it should be different for everybody. And the actual value that I want to put is the position of the sphere, but I would want to ignore the y position, so let's give it a new variable here. Sphere pos equal transform position and sphere pos y to be 0, and set sphere pos here. Right. And now you have the character marker mat property on the inspector of the follow. So let's put the material for the character marker here. And if I play it, what I hope to see is the character moves and the marker on the floor moves as the character moves. Corresponds to the character's position. And that's it. Let's make it more drastically change to make it more interesting. I'll set the wave scale to 4, the base radius to be 1.5, and wave scale to be 2.5. And let's set the speed to 7 and play with a maximum size. Yes. Good, good. That's it. This is how you can make a character marker shader. Okay. Thank you.